my name is Daniela. We are going to talk a bit about HTTP2 today and also about Nodejs. You probably know Nodejs, otherwise you won't be in this room, right? Who uses Nodejs? Okay, cool. Most of the people, so that's cool. Let's start. So a bit about me. I actually code at YLD, as Miles said. It's a UK company. I do quite a lot of Node.js and React. I organized the JavaScript meetup in Lisbon, which is called RequireLex, so if you ever visit, please talk to me. And I live in Portugal, quite far away. I'm still a bit jet-lagged. I like photography, and I also used to play guitar. I'm not a good player, but I learned from YouTube. So you guys can try to sing with me or something like that afterwards. So about HTTP. You guys may have heard about it. It's the protocol behind the scenes where both servers and clients communicate. And basically it had several versions so far. In 0.9 we only had body, no headers, no metadata. It's just about the content. In 1.0 we started to have some metadata. We started to have one connection per request, so we have one request, you are requesting the index page, a connection, it's open, and after you receive the file, basically the connection is closed. In 1.1, basically what happens is that we started to have keep alive connections, so instead of closing the connection after a while, the connection could be reused. Today we are going to talk about HTTP2, and it is important because it has some performance improvements, and actually it tries to change some of the things we had in Age 1. So in Age 1 we also had this thing called HTTP pipelining, and the idea is that when we request a file, because the connections are kept alive, you can request more than one file after the TLS handshake. And as you can see here, these two files, the HTML and the CSS, can be processed in parallel, like I have here, or in FIFO. However, it could create a problem, and this problem is called head offline blocking, and not hell. And basically, what happens is that when one packet is lost, because we need to guarantee strict in-order delivery, basically all the packets have to wait till the other one is retransmitted, and this is not good. Our users have to wait. Yeah, that's not funny, and this is one of the reasons why we want a new improvement in the protocol. And I would say that the main reason, besides all these things, is that because we need people first. So we want to deliver the best content for our users. We have people around the globe. We have people with different accesses. So if here in New York you have different connection than the one I have in Lisbon or in non-developing countries. So yeah, we need to have all these considerations. And this is quite important. That's why Google made a study a while ago in 2012. And they try to observe how the bandwidth and the latency vary in time, taking into account the page load time. And what they concluded is that if the latency decreases in a linear way, the page load time also will decrease. And basically these were the results of Speedy investigation. Speedy is quite of the HTTP2 father. So it's a protocol created by Google that is quite similar, despite some minimal differences. So HTTP2, it's here for quite a while, not that much, but it's being tested. And I could say this, it's the father. So most of the things are quite similar, and if you take a look at the RFCs and how they evolved, you can understand the differences. So I'd like to explain HTTP2 with a bit of music. I said in the beginning that I love music. I bet you guys also do. So are you still awake? Do you like music, everyone? Okay, I play guitar really well, but I love to go to concerts. And in particular, there are some concerts that I don't go that often, I have to confess, unfortunately. But I love them. I love to go to orchestra concerts. And if you go there, you can see that there are different people in the room. You are an attendee, you go, and they are different musicians that they are organized by instruments. And they are playing something for us as an attendees. And the music that they are playing is actually being sent. And it's like quite in HTTP2, it's like streams. So you go to attend to some concert, and there's different people there. There's the clarinet, there's the cello, people that are playing cello, people that are playing saxophone, and so on and so forth. And all these people are giving you different inputs and different streams. So in HTTP2, you have different frames coming along through the streams, and actually you can create some messages. And the messages are created on each of the ends. It could be the server that are receiving a message, or it could be the client that is receiving the message, depending on who is receiving it. In the case of the orchestra, they are creating sound, and that's why we attend there. So in HTTP2, there's this concept of the streams can be multiplexed. We talked in the beginning that we had this problem of head-of-line blocking. We had the information going back and forth. But what happens in HTTP2 is that we don't need to have this strict in-order delivery, because the frames are going to be joined in the end. It could be the client or the server, depending on who is receiving it. And basically, when you go to a concert, you can have some prioritization. You can watch the guys that are playing saxophone doing a solo, or basically they could start the song by themselves. The first 3 minutes are played only by saxophones. So in HTTP2, there's also something a bit similar. Basically, the browsers can say that some resources have priority to be received. Imagine a JavaScript file could have more priority than receiving an image. And actually, this was already a bit done before HTTP2. If you see some websites, you can see this priority column here. It's more or less what I'm talking about. There's some files that have more priority than others. But there's also something really important when you go to a concert and when they are playing. They can play, the saxophonists can play the whole song, like they can play for 10 minutes or 20 minutes, or they can play only 3 seconds, because they are doing something in the middle of the rest of the concert. And in HTTP2, you also can have a large amounts of data frames, or you could have only one frame because there's nothing else to be sent. And this information is sent in binaries. So we were used in HTTP1 to have data in plain text. In HTTP2, it's basically binary content. The idea is that it's more secure, it has less headers, and that's basically it. So when you also go to a concert, sometimes you can understand that the musicians are going to play by looking at them, or by looking at the person that is guiding them, by looking at his hands, like it's doing some gestures, and you can understand that they are going to start, or that they are going to end. You can understand that. So in HTTP2, there's also headers. So when you go to a website right now, the EmpireConf website, you can see that it's mainly using HTTP1. There's also some contents that are not, but the contents that come from the server that they are using, use H1. And if I open this image here, I could have picked YLD, come on. If you look at it, you can see the request headers and the response headers. These headers would be sent in this header message right now. So every time you have some message to be sent and to be delivered from one end or to the other, you need to actually send an header first. And there's also this important notion in HTTP2 There's header compression. There's a whole RFC behind it. You guys can check it. It's called HPAC. But the general idea is that when you send a message from the client to the server, or from the server to the client, and if this message is really, really similar to one you just sent before, you just sent the differences. And yeah, that's quite cool from one point, because you don't need to send that much data, so the data is compressed, as the name says. But on the other point, both server and client have to guarantee that they have the necessary information to keep the state. And this is one of the features I like the most. When you go to a presentation, or when you go to see an orchestra playing, you actually receive some information first. You get a brochure, or you get a quick presentation about the orchestra you are going to see. And in HTTP2, there's something really similar to this. So when you go to a web page, when you go to the index page, you can actually, if you are the server, you know that the person is going to need some CSS files, some JavaScript files. Actually, in HTTP2, these files can be pushed ahead to the client. And what happens is that the server already knows that they are going to be required, and it's much faster. In HTTP2, there's also this notion of flow control. So if you are seeing an orchestra, you have the orchestra, you have the person that is helping the orchestra, the conductor, you have the attendees, and there's also some people in the room. They communicate between using applauses and sound. And in HTTP2, there's also something a bit similar. Both client and server have to negotiate some parameters. And there's a lot of organization here. So I actually did a quick inspect of the network using the Nodejs current website. So if you look at the Nodejs website, you can see that there are many things here. This is an image, some text, and so on. And if you actually see the network, you can see all the files that are here, some PNGs, and so on. And what I did was I picked Wireshark, which is a tool that helps you to inspect the network. And I basically tried to gather some data. Why not? So you can see here that we have some packages using HTTP2 protocol, right? Oh, that's cool. Some data frames, some headers here. OK, cool. And I actually can try to filter by them. So there's quite a lot of frames going on here. And I can see that the first one is this one, 292. So if I go to 292, I can actually go back and see here, it was exactly where the connection started, and the client tried to say, hello, I'm here, and try to initiate the TLS connection and create the end check. So if you look at the details, you can actually understand that the client is trying to negotiate the ciphers, but there's also really something important here, which is this extension called ALPN, Application Layer Protocol Negotiation. And the idea is that the client is trying to say to the server that, hey, I support HTTP2. Do you talk HTTP2? If you don't, let's try to talk SPDY or HTTP1. And after a while, you can see that the server answers, and there's the continuation of the end check here, and you can see the ciphers and all that stuff from the TLS connection, and you can see that, hey, the server also communicates HTTP2. Let's talk HTTP2. So you see that they are changing some certificates here, some technical stuff. And then they finally start talking HTTP2, is everything ready? So let me try to filter again by the HTTP2 frames. I will abbreviate to H2, okay? And basically you can see all the things that are going here. And what I did was also filter by one stream in particular. I decided to pick one just for the purpose of this example. So you can see that here, this was initiated by the client because you can see in the source that it's my IP address. And you can actually understand what's going on here. So if I go to the details, I can see, oh, this is the logo.svg. So if I go to the oops, not this one. If I go to the image itself, and if I go to the elements, you can see that I actually have it here being included by window. That's why it's being requested in the Wireshark. And this was a request by the client. After a while, the server will answer with some headers and data. And the headers have all the information that you are used to see in the DevTools. So you can see, for instance, the content type or the cache control being set here. And eventually the data with all the information. So let me go back to the slides. Yes, we talked a bit about the protocol itself and what are the differences, but you guys probably want to know how to use this with Node.js. So I should start to say that there were some implementations in Node.js with actually some years, like 2 years, but they didn't cover everything from the RFC. So it was in version 8.4 of Node.js that this was added, this flag here, expose HTTP2, and currently you can actually use it in Node.js under this flag. It's still experimental, but I guess it's going to be in few days. So basically, you can take a look at the documentation. It's quite nice. I took a look at it, but yeah, it's still experimental. But it's quite easy to understand. And actually, it's not that difficult to create a secure server using HTTP2. So it's more or less what we are used to do with HTTP module. So in this case, I just required H2 and basically set some options with the certificate information and then created a secure server with that options. And actually, you guys can check. I created some examples for this talk. Unfortunately, I don't have time for them all. But you can play around and see this GitHub link and repo with all the information. But yeah, you may say, Daniela, I loved it. HTTP2 is really nice. I love server push. It's awesome. Why can't I use this with can I use this with Express or Happy? Because I'm quite used to these frameworks. I want to use it. The good news is that, or better, the bad news is that you need to wait a bit more. The good news is that it is being implemented and it should be quite soon included. And actually, if you go to the examples I've showed you, I have, for instance, for the Happy one, which is the one I'm more comfortable with, it's not yet in place, but I expect it to be similar to what it was before with other implementations. So in the case of Happy, you have to add a listener and create the server setting this listener with the options. So it should be quite similar to what we are expecting, and in particular in Happy, it's going to be in Happy 17. So, and it should be in the end of this month delivered. So I hope you guys can actually use it. I couldn't end this presentation without talking about server push a bit more. So I created this example here. So imagine that you have already created your server and you have a request handler. And actually what I'm doing here is just an example using the server push. So if your user goes to the index page, I'm actually trying to push a CSS file here. And I created this auxiliary function where the magic is in this line, stream.pushStream. And actually what we need to put here in the path is the path that is going to be used by this image. In this case, it could be image sponsors, Condé Nast in this case. And then you can basically respond with a file or with a file descriptor, as you can see in the documentation, if you check it. But yeah, server push is really cool, but I was wondering, wouldn't it be even cool to use it with service workers? So if you guys attended yesterday to the workshop that Bradley did about PWAs, you probably already know that service workers are really powerful. They basically help you to intercept the fetch requests that you are doing. So every time the browser tries to go to the network and tries to go to pick, for instance, this image, it could actually intercept all the requests. And the major thing that it can do is to cache all the things. And that's quite useful, right? And basically, I did an example here. Let me show you. So I have HTTP2 server here being created. In the end of the file, I'm basically creating it and listening on 3000. And I have on request handler, like the one I had in the example previously. And yes, it's basically just a simple server, nothing special, that handles the index route and also for the service worker or some file in the public folder. And actually, what I'm doing is pushing some stuff. So here in the index route, I'm pushing a CSS file and a JavaScript file. And I'm answering with this index.html file. So if you guys look at the index.html file, you can actually see that both the CSS and the JavaScript one are being requested here. So what is expected to be seen is that because I'm pushing the resources here, these files will be already cached when they need to be requested by window. And let me just show you the service worker. It's quite simple. I'm basically installing and sending and telling the service worker, hey, please cache these files. So it's going to cache the local host, the GS file, CSS file, and so on. So I basically created this. It's like a simple thing going on. And as you can see, I am pushing, you can see what was pushed here in this column initiator. And you can see that I'm pushing the CSS and the JavaScript file. And it's saying that my service worker is pending. And if you look at the console, it's saying, oh, you don't have a certificate. Too bad. So what I did as a lazy person, because I didn't want to have that much time, and oh my god, that was quite a lot. Spoilers on the other side. But I basically decided to open Chrome with ignore certificate errors flag. Why not? Come on. It's not production, I just want to play around. Let me play. And actually, this is what I have here in this one. So I added, Chrome was really kind, is saying, oh, you are using an unsupported command line flag. Come on, let me just play. And yeah, you can see here something interesting. That is, yes, we are using H2. The files seems to be requested. The service worker is here. Awesome. If you take a look at it, oh, it's here. That's cool. And you can see the cache also. So you can see that the things that went to the cache. In the case of this case, all the files that I placed in the other side. We can also see some other thing that is quite relevant, which is what is happening here is that I was sending this file and I was asking it to be cached, right? But when I look at this, the service worker is trying to request it again, is making 2 requests. Actually, if I take a look at the terminal here, you can see that it is basically making a request, and it's pushing the CSS and the JavaScript file, is sending the image also, and then it is requested again, and I didn't understand why. So what I actually did was basically install the certificate. So basically, I used Let's Encrypt. I don't know if you guys heard about it, I hope so. But basically, it helps you to create a free certificate. So I added the machine to DigitalOcean and set up all the things. And fortunately, with this solution, you can see here that it's bringing it from the disk cache. Awesome. So I had to actually create a website, put everything in the machine, set up the HTTPS connection, and everything worked fine. So in this case, I hope you can see if I haven't set up all the logs. But if I do, maybe it's closed. Let's try to create another one. Go. Okay. So if I look at the logs, ignore the warnings, they don't matter. You can see quite a lot of stuff. Let me just try to show you a bit better. Because if I open a new connection here, oops, and just go to open the console, press enter, and see the network, you see the same that I had before. And if I go here, you can see, fortunately, it's only being requested once. It's on the disk cache, so it's quite different to the other one I had here with one more request. So let me go back to the slides. Where are them? Yeah, so some learnings about this. There's something quite interesting that I didn't talk that much about. That is the credentialized requests. So there's something also important in HTTP2. We are using H1 to have a maximum of 6 connections. In HTTP1, the idea is to have only 1, no more workarounds. And actually, there's a trick that you have to do inside your service worker. You have to set the credentials includes, otherwise it will create a new connection. Let me try to show you. So if I save this, and if I actually try to reset the server and go back to my fake Chrome, and let me try to clean all the things and show you. I hope. You can see here in the connection ID that it has different connection IDs, and that's not what we want. In HTTP1, we only want to have 1. So we really need to do this trick of having credentials included, otherwise it will not work as expected. So this is one of the points. The other one is HTTPS please. So we were talking about the TLS connections. I had to set up all the things. And this is actually really important because all the browsers have to set up everything here. And the browsers don't let you use HTTP2 without setting HTTPS and the TLS connection. So please do it. Also, if you like service workers and all these things, and I participated in the last edition of Offline Camp in Berlin. It was awesome. So the guys behind it are really awesome. You can see my face here as well. And it was really nice. So I would recommend you. The next one is going to be quite close, at least for you. Yeah. So please check it out. Or if you have some friends interested in this, it's awesome. So to wrap up, HTTP2 is quite powerful. Server push feature is amazing. You can play a bit with it. It has some concerns, but yeah, HTTP1 is still going to be here for at least a while because people need to update their servers and also the browsers. Most people don't update the browsers, so there's still some people using older versions, and you need to have all these considerations. Also, HTTP2 is starting to be more widely used, but there's not yet like a lot of people using it. It's less than 20% of the websites over the web. So it's something you should definitively check out. I hope you do, and I hope to give you some hints with this presentation. And I guess that's all. Thank you for inviting me to be here.
Thank you. I really liked the analogy with the orchestra.
Thank you.
So they say sequels are never as good as the original.
What?
Can HTTP2 stand the test of time?
Stand what?
The test of time.
The test of time.
Will it outperform HTTP1? Will it replace it?
That's a good question, because there's a lot of comparisons between H2 and H1. And actually, there are some people saying that it depends on the use case, but most of the times, yes. And we can test everything because not everyone is using it yet. So, yes, I would say.
So, Daniela, you're from Portugal.
I'm from Portugal.
And in Portuguese culture, people have longer names.
Yeah.
And would you share with the audience your full name?
Fortunately, Miles asked me beforehand to do that. Otherwise, I would be really conservative. But in Portugal, we basically have our whole family names. So I have family names from my family and also names from my husband's family. So my whole name is something like Daniela Alexandra Esteves Gil Borges Matos de Carvalho. So it's quite huge.